Right, welcome. Let's solve some base exercises together. So now we have a factory that has three machines. It has machine 1, machine 2, and machine 3. Machine 1 is accountable for 40% of the production. We don't know the value from machine 2 and from machine 3. But we do know that the defects from machine 1 are 4%. The defects from machine 2 are 2%, so the parts produced from each machine. And the defects from machine 3 are 1%. And we are also told that 97.45% of the production comes without defaults. Right, so using the total probability theorem, what we now do is use the values, but because this is a total production without defects, we're going to switch these values around. Think about it, because if in one branch we have 4% with defects, that means we have this other branch with no defects. So doing this, we have 0.9745 is equal to 0.40 times 0.26 plus the percentage coming from machine 2, which we don't know, but we know that comes from without defects, which is 98. And the same thing from machine 3, that comes without defects, so 0.99. But now we also have another term that we can use to solve this, because we know that this needs to equal to 100%. So this means that 1 is equal to 0.40 plus machine 2, some percentage, plus machine 3, some percentage, which we don't know as of yet. Okay, so let's keep going. So you're going to multiply this value now and subtract it from here. So let's do that. We get 0.5905, and then we have 0.98 M2 plus 0.99 M3. And now we're going to do the same thing for this value. So 1 minus 0.40. Then you just take one of these to this size. It really doesn't matter. So it's M3, let's say, equals to M2. Okay. So now we're going to get this value. So this is 0.60 minus M3 is equal to M2. So you're going to get this value here. So it's 0.5905, it's equal to 0.6 minus M3, 0.98. I just took the math from this value and plugged it here, okay? 0.98 plus 0.99 M3, okay? And then you're going to get the resulting values from here. You're going to get 0.5905 is equal to 0.588. Remember, we're just doing the multiplication with this one and with this one. So this one is 0.588 minus 0.98 M3 plus 0.99 M3. Okay? So then you're going to get 0.0025 is equal to 0.01 M3. So you get this fellow over here, and we are going to get that M3 is equal to 0.25, and then when you substitute 0.25 here, because we already know the other one, we're going to get that M2 is equal to 0.6 minus 0.25, which is equal to 0.35. Okay, so now that we know the percentages from this one, and the first one that we know that is 40, we can complete the tree. So the first one is 40, M1. The second one is 0.35, M2. And the third one is 0.25, M3. So keep going with the nodes. And the second one, we know that the part one comes from defects is 0.004 defects. This next one is 0.96, no defects. This next one is 0.02 defects, so 0.98, no defects. And this one is 0.01 defects, so 0.99, no defects, okay? So doing the math, we get 0.016, 0.384, 0.007, 0.343, 0.0025 and 0.2475. Remember, as a sanity check, sum these up and you're going to get 1. If you don't, you messed up the calculation somewhere. So Now we are asked what's the probability of coming from M1 knowing that it has a defect. So a part coming from machine 1 knowing that has a defect. Again, we follow the same logic. So in the denominator, it's the probability of having a defect. And in the numerator is the probability of coming from machine 1 and having a defect, which is this branch, and this branch. So the values below are 0.016 plus 0.007 plus 0.025, and on the top you just plug in the one that we are asked in the question, which is M1D, which is this one. So 0.016. So you do the math, you're gonna get that it's 0.6275.